Buddy, you want to go ahead and get started? There's some new faces here today, some familiar ones, but we could go ahead and go around the room and just give your name and introduce yourself. I'm Roy, I'm Hoop, I'm KJ5IUL, that's my ham call sign, and been part of this meeting since the get-go, since Steven put it together. And I'd like to thank Steve for allowing us to have this room, Steve Hazelwood. It's very generous of him to allow us to have this space to meet. We'll go ahead and go this side of the room.
I'm Adam, amateur call sign KD5EF. What else do we say, just that?
That's it. Yeah.
I'm Paul, I'm as green as you get.
Oh, one more, back in the back.
Steven, WY6Y, just Cameron guy.
Another Steve. We got three of us.
All right. All right, so we got three things here we're going to give away. The first of all, if you're into Meshtastic, this is a big honking antenna that you can actually hook up to your node. And if you do happen to have a place like outside your house or even in your front window, like I have one of these set up, tend to get pretty good range with it. Works pretty well. Maybe a great addition to your network. So we're going to go ahead and give that away. Let's shake up this. All right, and let's see, Kent Wheeler. Kent, all right. You are the proud new owner of a boomstick. There you go. All right. The next item that we have to give away is a Raspberry Pi 3B with a case. I've got it disassembled, but you can put it back together relatively easily. It's got the power supply, and it's got I think I've got a 128 gig memory card in here, and it's got the Raspberry Pi operating system already flashed to it, but you can, of course, go to the imager and put whatever you want on it. Run Linux, run anything you want. Go ahead and give that away. And the winner is, oh, that's the same one. Okay, the winner is Steve, K5IV. All right. Here you go, sir. There you go. All right, and last but not least, we're going to give away the whole damn box. This is a generic Pelican case. They work pretty good, actually. And this is going to go to, same name I grabbed the last two times, Don Mosier. There you go, Don. You get to throw away all the names that are in there. Yeah. All right. All right, so I'm going to go ahead and get started on this. Several months ago, there's a bunch of us that are on a Telegram channel. I think Chuck brought up, we've got these sites in Oklahoma City. We've got Sand Ridge, we've got the grain elevator, and now more recently we've got the Physical Science Center down in Norman. These three sites these locations have three things in common. They've got permanent power, advantageous height, and they've got the ability for us to put a fair amount of equipment on these sites if we want to. We're not limited to a small space. So we started thinking, well, it'd be a good place to put Meshtastic. So we put Meshtastic there. Let's put Arden there. Arden is for those of you who don't know, is the amateur radio emergency data network. It essentially is a all IP-based network that runs off the microwave frequencies on the 2.4 gigs and 5.8 gig. Any service that you could run basically on the internet that is not encrypted, you could run on Arden. Is that an accurate statement? Yeah?
Correct. Actually, you can run encrypted if you publish keys.
Bingo. Okay. Well, so it's a very, very robust network, and we've got it spread all across Oklahoma City. The network can completely operate offline outside of a central structure, outside of a central internet structure. And so we started thinking, I believe it was Chuck. Chuck always has ideas. Chuck always is coming up with ideas. It's just harebrained ideas that we throw around and kick them around. And we say, well, you know what? That might have some legs to it. We thought about what could we do if we took Meshtastic traffic or allowed Meshtastic traffic to go across the network and connect to the Arden network and share it over the Arden network, or use the Arden network to extend Meshtastic traffic. What happens if we took sensors and added them to the Meshtastic network and took those and aggregated those into some central piece of equipment combined with some sort of scripting mechanism and allowed us to basically have a central brain for a network. And that's basically the whole thesis of my presentation today. It's called Bridging the Mesh. And you know what sparked this idea is you start looking at my career in amateur radio, which is very brief. I've just started out. And over the course of exploring, I think like any other amateur, when you first start out, you start just looking at all this equipment, and you see Yaesu, and you see ICOM, and you see all these different radios, Baofangs, and you start studying about what they can do. And really, you kind of run into a dead end. At the end of the day, it seems like over the last several years, I think recently, like these radio manufacturers have failed to include any forward thinking in their designs. And there's a lot of discussions about, what's that?
Preach on, brother.
What?
Preach on, brother.
Yeah, and I mean, they've, other than adding some maybe higher quality voice, maybe some SDR on the HF bands, or maybe plugging some APRS into a handheld, none of these guys have really started to think about what is the next generation of technology. Well, I've started going down the rabbit hole of looking at these single board computers like this Raspberry Pi. Well, that's a 3. They're now at the generation 5, and there is a AI hardware accelerator device that you can put on the single board computer that allows you to run offline large language models. Well, what does that do for our network? I think whenever you take a look at integrating things like Raspberry Pi into our network, into Meshtastic, it gives us some exciting features. It gives us some things that we could do, ways to aggregate data, ways to translate IP data, integrate things like Node-RED, and pretty much serve as a central hub for our network where we could start offering advanced features over this network that nobody's doing. Here's the two networks. Arden, and just like I said, Arden is utilizing the ham frequencies that operates on the 2.4 and 5.8 gigahertz bands. Backbone connectivity across long distances. We got bandwidth application, higher bandwidth applications and web services, things that you can't do on Meshtastic. Over here on this end, you've got Meshtastic, the thing we were all talking about, all of the little devices here. 915 megahertz, low bandwidth. Mobile peer-to-peer networking, and ideal for text, GPS sharing, and sensor data. Easily deployable, very low price point to get into. Doesn't do data very well. Doesn't do much other than send messages. And
Little tiny bits of data.
yeah. Both these networks have blind spots. So on one hand, we've got Arden, fairly difficult to get into. If someone was going to go visit the Arden website and start to flash a router, it'd be a process. You would have to work through that process, and there's a little learning curve there. Fixed infrastructure, it's with those frequencies, it's a little bit more prone to foliage, will disrupt your signal. Complex barriers to entry to set the network up. Meshtastic, limited bandwidth, restricts heavy data applications, no native IP-based web services. More so on Meshtastic too, it's isolated islands without broader connectivity. Basically, if you're on Meshtastic, if you're in a hole somewhere, you might be able to get to your neighbor. You might be able to get maybe a mile, 2 miles. If you're lucky enough to have visibility to one of the sites that, like Sand Ridge, you're going to be able to extend your range a little bit more. What we're bringing to the table is a hybrid solution, combining these two networks with complementary strengths to leverage Arden's bandwidth to extend the network, and also utilize its robust backbone. And we're going to go into that here in a minute. So the time is right. Arden exists, but it's underutilized. We've got probably one of the better networks, I'd say, with Arden in the state. If you look at the map, there's a lot of traffic on it. I was just cruising through some of the services that people are running on it right now. I mean, it's pretty amazing. It's pretty cool that we've got a PBX set up and a conference bridge so we can enjoy all IP calls over RF. With basically, you could add multiple users onto Arden, onto the...
3 PBX.
Yeah, 3 PBXs. So that's one of the really neat features, crystal clear IP calls. Meshtastic is growing. Nodes are popping up everywhere. But again, very fragmented. So we've got the gear and we've got the people. So here's the opportunity that we're looking at. Let me go into a little bit about some of the thinking that when I started thinking about Meshtastic, more and more these days, I start thinking about what is Meshtastic really valuable for besides texting? And to me, the light turned on and I was like, okay, sensors. Basically, you can connect a number of sensors to monitor wind speed, barometric pressure, weather, and you can collect all kinds of data on these sensors. But right now, other than like looking at that on your phone, there's nothing you can really do with that in terms of utilizing this data that's very valuable that you could use in a more advanced feature if you had some sort of central device that you could take and analyze all of this data. Basically, here's basically some Arden features. We've gone over this before. Arden's got the VoIP. It's got mesh chat. One of the other things on Arden is the cameras, that you can connect cameras to it and run cameras on it. That's just basically a slide going over that again. So here's the approach. Okay, 2 networks, 1 unified flow. So Arden, the command and control layer that hosts dashboards and services, would provide high-speed bandwidth. Meshtastic, low-power mesh messaging, long battery life, low cost of entry. Now here's where it comes. Here's the interesting part. Here's the bridge. This is what we're here to talk about today. Utilizing Raspberry Pi as our gateway with MQTT and layer in some offline AI and machine learning elements to run on the Raspberry Pi, we're going to create a unified flow and a unified network that we can accomplish all kinds of cool things with. Raspberry Pi, it's our Swiss Army knife. We got a LoRa radio interface on it. You can connect it to a Station G2, a T-beam, the new FemtoFox, which some people are using, which is a very low power drain but high power output hardware device on Meshtastic. You can utilize an MQTT broker. We'll go into more about MQTT here in a little bit, but that essentially is a message translation and queuing layer that you can subscribe to topics and publish to topics and send those across the networks. Here's where it gets real interesting. We're going to add AI processing, a lightweight AI model that sits on the Raspberry Pi and runs on the Raspberry Pi that takes the data from this network, aggregates that data, learns from that data, and provides us all kinds of neat features moving forward. We've got our network connection through Arden. We've got our Ethernet backbone covering all of Oklahoma City, tying this all together. Here's how messages could potentially flow through this network. Arden node receives an HTTP post to the Pi. The Pi publishes it from Arden to MQTT, and the subscriber forwards it to a Meshtastic API. Meshtastic to Arden, the LoRa device is connected serial to the Pi. Pi publishes it from Meshtastic, delivered to Meshtastic or Node Red, which we'll go into more in a little bit. It's a little bit of an automation dashboard. The AI offline, we're going to run this all offline on the Raspberry Pi using one of the models like Tiny Llama or Pi 2. It could flag critical messages coming in from this network, such as alerts, tornado alerts, gas leak, collapsed building. Aggregate those and push those out to the network to all the users on the Meshtastic network. No cloud dependency whatsoever. We could run this all on that Raspberry Pi. Not his Raspberry Pi, but the one I'm going to show you here in a second. Here is what I've been looking into. And I just threw a name together, called it the Mesh Bridge Unit, the MBU. This is the experiment. It is a device that's available right now for approximately $249 built. You could get that at Seed Studio. You could probably put one together, but the two essential components of it are the Raspberry Pi 5 and the Halo 8. The Halo 8 is the hardware accelerator that runs 26 tera operations per second. I don't know. I'm not an expert. Again, I'm not here to teach you. I don't know what that means, but what I'm told is it can do a lot of really cool stuff when it comes to machine learning and AI processing. And what it can do, just to give you, I mean, probably 5 years ago, you'd probably have to pay $20,000 to have something that was that robust and able to accomplish that. Dual radio connectivity, we can connect a femtofox, or we could connect station G2, basically any one of your Meshtastic devices. That ties into your Microtech router. We've got bidirectional message flow with MQTT handling traffic between LoRa and IP services, mesh chat, and dashboards. You could power this off-grid if you wanted to. You would need about a 20 amp hour battery because the Pi 5 is going to run at about 5 watts, the AI processor about 2.5, and the femtofox would run about a half a watt. So with the adequate solar panel, you could probably keep this thing, the battery would run about a day, double the battery size, and probably get 2 days. The sites we have, we could run them. We've got access to permanent power. If you got access to permanent power, you could run it on that a lot easier. Your node services, it hosts an MQTT broker. We could run AI triage Python scripts to push to local dashboards. All this is open source and module. All of these libraries are all available. This is not proprietary hardware, proprietary software. Everything is out there, and the amount of information that is out there and the ability to develop this stuff is just, it's incredible. So why is this important? I think this is a little flow of what I'm looking at. So say, for instance, a Meshtastic node sends a message out on one of our channels, building collapse, 2-trap from disaster site. This gateway takes the message, pushes them through to the Arden network, possibly through Mesh Chat. Mesh Chat, there's someone in Arden, we have an Arden command center that receives the alert, coordinates responses, and sends it back. Field teams then could take this information on their LoRa devices, on a portable LoRa device, and then send and relay messages based on, you could monitor their GPS locations, where these people are, send messages based on coordinates. So in the event of a disaster, this works out, it provides an awesome infrastructure that we could have for emergency response. But not only is it something that you could use in emergency, I think this is something that would be really cool to use every day. You've got it, back to what I said with the sensors. I think we're really discounting sensors in Meshtastic and the data we can collect from them and utilize on a daily basis. We could really take this data from these sensors, push it into our central Raspberry Pi unit, and start aggregating this data, visualizing it, making dashboards, using data on an everyday basis. Also, with the offline LLM, we could it could serve as a knowledge base. Say you're out in the field and you want to send a question. You could send, like, for instance, Adam's got a bot, R2D2, that runs on his Meshtastic node. You can ping it with certain questions and it'll come back with responses. Well, adding the LLM component to this really provides you a lot more robust feature set with that. Mesh Chat from Arden, pushing information to LoRa field devices, just people that are on their computer, utilizing Mesh Chat from their desktop, pushing it out to the field. How do we fix the encryption issue? This is the thing. 2 separate networks. One of the things about Arden is it is a Part 97 network. It runs on the ham bands, so you have to ensure compliance. Meshtastic by nature is encrypted. You do have the ability to publish, to send unencrypted messages through MQTT on Meshtastic, as well as publish a predefined key that could be shared. So you get over the encryption portion right there. Part 97 just goes into a little bit the challenge. Amateur radio transmissions can't use encryption or share the meaning of a regulatory authority. Public shared keys, using a network published key, regulatory transparency, protecting against casual interference, unencrypted channel operation. Basically, We all know the FCC rule on encryption is one that we all wish would go away. Go ahead, Chuck.
Yeah, with the FCC's delete thing that they're wanting to clean their mess up, a lot of people are submitting requests to come up with a solution to this because all of the tools are encrypted now. So it makes sense. I mean, let's face it, you can probably sit there and run stuff over Arden that's encrypted, nobody says a thing. But the first time somebody decides to take a whack at you, you're exposed. We need to get that changed. So there's a large group of people that are trying to, ARRL isn't worth much, but,
Yeah.
because I saw their thing they're requesting and that didn't get much attention. But the people, all of us that have to deal with this, and one of them that was mentioned is our buddy up in Canada, and his group are pushing hard. The Arden group is pushing hard to come up with a solution because you just can't get unencrypted tools anymore.
Yeah. Okay. So how do we accomplish incorporating a new hardware device into this network to accomplish some of these advanced features? I think we start small. I think you could start testing this at home before people could run service integrations, add Node-RED, Mesh Chat, and the MQTT broker, and then our strategic deployment. Deploy them on our sites where we've got advantageous height, where we've got access to permanent power, and where we do have adequate space. Field test them under various conditions. We got to start somewhere, guys. One of the key things that this whole idea revolves around is we've got to start bringing some coders into the radio group. We've got to get some people that are solid with programming, or willing to learn. I think it is absolutely going to be something that we can leverage some of these incredible features and really push some features together in the future that we could not do before. And it's absolutely the way to bridge these hardware devices together. Use Oklahoma as a model. Your expertise, all of the people in this room have various levels of expertise. I know Hauser has developed an amazing little tool using Raspberry Pi. So we've got a lot of people in this room that are already getting started with Raspberry Pi. Don's got some experience with it, building all-star nodes. Need everybody in this room that could provide some level of input onto a project like this to move it forward and really put Oklahoma on the map. Here's where we need your expertise: network design, hardware, software development. That's the big thing. I think with the software development, that's going to be one of the critical pieces in putting together something like this. Here's the twist. So adding voice infrastructure to the mesh bridge units. Chuck talked about this. This is one of Chuck's ideas here. Incorporating DMR repeaters through Brandmeister, analog all-star modes, and through the Airden mesh nodes. We use utilizing this network. There's some people that are already doing this today. AH6LE from Oregon is using all-star nodes linked entirely over the Airden mesh with zero internet dependency, complete off-grid voice communications. There's another ham in Florida, N4TDX, that's using Brandmeister DMR repeaters and using the Arden mesh as backhaul. And then there's a real cool project with W2YMM in New York that's using all-star nodes with a switch to create analog to DMR linking. So these are some real-world projects that you can go look up today that are...
We're doing that here.
Yeah, okay.
We got 3 DMR repeaters that use it. And we've already tested out network failure, didn't intentionally do it, but it failed at my place and rerouted down to Norman, and all 3 repeaters continue to work.
Wow.
So is that an enclosed system? So if you boot up a system like that that's running off of Airden, it's not on the internet, right?
It's on,
You're enclosed.
you could run it entirely over the Arden IP network, yes.
It'll just be Oklahoma City.
Yeah, and well, Arden's linked beyond Oklahoma City.
Like the DMR repeaters,
Yeah.
they're on Brandmeister. So they go out pre-established ports out
can link across to the internet at different node points if the node has an internet connection. So even though that repeater site loses internet, Arden can let it back out to internet on another site on the Arden network.
Okay.
We gateway that too, so we don't.
Okay. Well, I thought the whole point of this was getting off grid.
Well,
Everything I ran into on this, you're right back at the grid every time you're getting back on the grid.
okay,
Someplace-
we've
place-
got a guy here, a developer, the guy that did the tunnel server and the supernode server. He's got a DMR master at his house. And we've got a couple of the MMDVM based DMR repeaters that use DMR gateway, and you can use his or go to the Brandmeister. If you use his, it's all on Arden.
I didn't either.
Okay, and so again, we're looking at layering different features into this network, but I think the fundamental premise of this and how this basically operates is everything on here would be offline. We'd run the large language model offline, Meshtastic runs offline, and then linking together the Arden network, which the core of Arden network runs over RF without connection to the internet. That keeps it up and running. It runs outside of the internet. So we're talking about layering in future services onto the, again, this is all blue sky, big picture thinking here. One of the cool things that we talked about Meshtastic sensors, all-star voice coordination, and then one of the cool things that looking forward with doing something like this on the Raspberry Pi is able to take like a software-defined radio possibly and have voice, to be able to transcribe voice and aggregate the voice and push it out into text over the Meshtastic network. So that's another cool feature we're thinking about layering into this potential science experiment here. One of the things that I wanted to talk about projects like this that I see in the United States right now, our youth is horribly lacking in science, math, and technology. I think one of the core reasons why that we're lacking is because they get this and dumb it down, and there's all these apps on here, and they just push these buttons, and they don't know how anything works. And I think amateur radio is a tremendous platform to get our youth involved in science technology, because if we don't, we're not going to have any engineers in 5 years. And this whole supply chain thing that we have, we think it's bad getting electronics right now. Just wait in a few years when there's none of our youth are able to learn this stuff and develop solutions. I think projects like this, projects that take hardware, that take networking, and take programming and layer them into a project-based environment. This is something we need to extend our outreach just outside of the radio clubs to today's youth to get them involved on something like this, because when they can start coming up with applications, when they can start writing scripts and they can start grabbing these things like this and putting it together and connecting these antennas to them, developing dashboards, developing applications, man, I mean, that's something that has an actual tangible benefit. They can put their hands on it and something that they can do. So my call to action is, I mean, if you know people that are college students, high school students that want to learn and get them in radio, get them involved in Meshtastic, get them involved in amateur radio. One of the cool things about amateur radio, a lot of times there's people that are on one side of the fence, they don't want to jump into amateur radio. Here's my thoughts on that. They want the anonymity of utilizing an unlicensed network and utilizing the encryption. My whole thing is amateur radio gives you access to more spectrum that you wouldn't have to play around with if you didn't. So it's another vehicle to move you forward, and it's a great way to get people into the art, and we need more of it. Again, I don't have a blueprint here. This is just an idea. My call to action, and I will share with you all of my research. I will share with you some background information. If you want to shoot me an email, I'll send you kind of some of the thoughts behind this, some of the deeper research that I went down to come up with this presentation. But essentially, there are already people in the ham community. There's a project called Zero Retries that is utilizing the Raspberry Pi on the 70 centimeter band to make a radio that does data, albeit it's constrained at a lower data rate because of our limitations with bandwidth on the 70 centimeter band here in the United States. But nevertheless, the 70 centimeter band would provides you a lot more distance, a lot more ability to get around foliage and obstacles. And so this is a project that's currently in the works. We want to try to look to duplicate something like that where we can actually utilize these advanced little single board computers, integrate them with our radio systems, integrate them with tools like MQTT, and develop some really advanced solutions. And I think we could really set Oklahoma on the map. We got the right group of people in here. I mean, I've talked to all of you. I've seen some of the projects that you worked on. I think the time is just to come together and let's pick a project. Let's pick something to do. Let's take a bite-sized chunk off and let's divide and let's conquer and let's put a new cool solution for Oklahoma City and the technology community. That's my presentation. I appreciate you guys. Thank you very much. Thanks for coming.
So as far as licensing requirements, like if a person, hold on just a second.
I answer with no question.
Okay. Hello, I'm Adam. Okay. So my question is, suppose you have just a simple commoner on Meshtastic, and they're wanting to transmit through Arden. Is there an issue with licensing through? You have to have a ham radio license to use Arden. Would there be an issue there at that point if a common person were to transmit through Arden?
I think what this the solution here that we were thinking of was taking. So I don't think there would be a problem with taking traffic that would be on a Meshtastic channel, sending it to a central, call it our MBU, our mesh bridge unit. Say it takes a message, help needed at the corner of 5th and Lincoln, sends it through the gateway, publishes it to an MQTT topic, and then pushes it out over Arden to like Mesh Chat or another messaging program on Arden. On the other end, maybe this network, this message comes through via Arden. It's not encrypted. It's just data. It's just like a text output. So it's going over to Meshtastic. So it's just, that's kind of the vision that I had for it. So I'm not sure about the complexities of that. Go ahead. One of you two want to handle that?
As long as you have the amateur radio operator's ID put in the traffic handled by the Arden network, it'd be handled as a third-party operation and message forwarding.
Okay.
Oh, okay.
And the second part for that, you're talking about the AI part.
Yeah.
Okay, think about it a minute. You got a frame that comes along, in it, it's got some of the words you don't want on parts 97. AI says, nope, I'm gonna kill that, and sends a message back, you can't push that through. So that takes care of meeting that requirement there. That's the control operator, and the control operator's buddy is that AI that's watching for anything illegal going through there.
That's one of the cool things about AI. I mean, you could actually flag certain messages. You could parse that data out and just say, okay, if these words, if this, then kill message. Yeah. If not, if words need help, if directions, send message. You know.
Yeah.
And also in emergency, licensing is out the window.
Yeah, you don't need it. That's why I happened with the St. Helen hurricane. They were handing out radios to people that weren't amateurs.
If it is a true emergency, if there is imminent threat to life or property, you can operate on amateur frequencies or any frequency without license. Well,
So the other thing is,
Let me get your microphone.
Matt?
So the other thing with for Meshtastic and Arden is if you don't have an Arden node, your Meshtastic, you're only going to be within your own circle. So you have to have your own Arden node to actually get your Meshtastic on the node, which hence you need an amateur radio license. That makes sense. So if you want to get into the mesh, the node or Arden mesh, you need a node.
But in the case where we have what we consider, I said supernode, that's a misnomer, but where we would have these mesh bridge units like our OU Physical Science Center, we would have one at Sand Ridge, we would have one at the grain elevator. I think by having this intelligence built into those devices on the network at strategic locations, I think you're going to be able to have a lot more traffic pass through, aggregated through this Raspberry Pi, through this machine learning type device, and pushed out to extend your network, because those devices are at locations that can extend the network and provide us a little bit better coverage across the metro area. So while everybody would not have this level of intelligence baked into their home device, which you could, and adding those features, I think, to it on your own home network would just make this network more powerful across the metro. I think by having some of the access to this technology at strategic locations, we make some additional features available out into the network where we had previously fragmented islands of just Meshtastic networks. If that makes any sense, or if that's kind of where I was going with that.
Did that answer your question, Adam? You were talking about, there was the screen there talking about remote sensors. And one of the things that comes to mind to me about that is you've got, let's say out in the Southwest where we have all the problem with the fires. You've got sensors out there, and then you've got cameras like we're beginning to see. In fact, I've got some of them brought up here on this. And if you wanna pull them up on your screen there, I can give you the URL. So say we've got sensors out there. The sensor sends an alarm to, say, Stevens County EOC. The EM gets on the network, brings up the camera, looks in that area to see why that thing's alarming, and then figures out what he needs to send out there. And that's one application. The sensors are on Meshtastic. They send the alarm information back. The guy gets on closest camera and looks out to see what's going on. Is there fire? There's something. What is it he can see with the cameras? So that's where this combination really comes in handy.
That's spot on. That is exactly the killer app in this, I think. Yes.
The EM down in Duncan, he wants to extend that further. He's got a drone. It's like this big. He's a professional drone pilot also. And he wants to figure out how to integrate the video off of the drone into the Arden network. As it flies around, it hands off the video to the different nodes. And this is the county drone they fly to look at fires and stuff like that.
Did you have something?
Like I said, yeah, you can start tying in AI and analytics to your camera feeds, and then no one has to look at it. If that starts to see a certain level of fire, then that's going to create an automatic alert that goes out and sends it for first responders. And so a person never has to log in to even see those cameras. Yeah, that's a great feature. That's cool.
I want to know Yuri's thoughts on AI and integration of intelligence into Meshtastic or other radio networks.
I'm not sure.
Okay, fair enough. Yeah.
It sounds like it's doable. I just don't know exact application.
Okay.
All of them.
You also gotta look at the bandwidth. What the AI is pushing or receiving and pushing out. So that can handicap the whole Meshtastic network.
So say the AI device, your Raspberry Pi computer is receiving Meshtastic data through serial and analyzing this data, but it's running it through an offline library. Your library is ran offline. So you're not going to the cloud. So you're not bandwidth restricted there. You would just be restricted to the processor power of that piece of hardware, right? So really, you're not utilizing bandwidth because your intelligence is on the edge of the network.
Understand. So there's two things involved. The transmission, that's what I'm speaking about. I think I misspoken when I said
Okay.
processing. So there's a transmission and there's a processing. MQTT can take care of the processing. It's the transmission. If you go to the Meshtastic website, there's certain frequencies that you're running at that's limiting you to how fast you can process as fast as you want, but there's only so much information that's going to go across that Meshtastic from 900 megahertz, whatnot.
Understood. So the rate of data that the messages would actually come out to the network, right?
Right.
Okay.
But back to, you can always dumb it down and just get with MQTT or Node-RED, just pluck out the specific information that you need, or like a time interval. Every 5 seconds, kick me out the data. Example like for the fire with the, what do you call that, the drone? Look for heat signature at this temperature and only trigger when it's at that temperature or higher every 5 minutes.
Yeah, filters,
There.
yeah, filters.
I didn't realize what some of the topics were for today, but there's some interesting research and frameworks that have already been developed to do some of this processing at the camera level. One of the ones that I've been familiar with is called Wi-Fire, W-I-F-I-R-E. It's a funded project out of, dealing with the fires in California. And what they're doing is they're putting GPUs close to the cameras, getting the detection, building the models to be able to accurately detect. So then it gets relayed over low transmission from middle of nowhere. And then there's another one that a buddy of mine is on. He calls it the Internet of Wild Things, and he's trying to do off-grid and building on layers of technology here, and he's putting GPUs. So there's some interest in doing some of this. There's some interesting code that's already been developed that's been funded to be able to be available for this type of activity. And in Oklahoma, I think it's exciting that there's so many structures already in place, like, an opportunity to partner with maybe the Mesonet to put sensors out there. Anyway,
I think that
the Wi-Fi one is the one that made me think of when you started going down the path with the intelligence within the cameras.
I think
And one of the really cool things in the models that they did with that is they'll do, when they don't have enough capability for the detection remotely, they'll strategically push full high-res photos to models in a different compute location and take advantage of that. So there's some really cool processes there.
Yeah, I think the ability to collect sensor data just on a daily basis and aggregate that data and have something that provides a little intelligence to that. Yeah, there's some definite partnerships with some of the weather organizations, and that data is valuable. I mean, you're talking about hyper local data, like on a neighborhood level, on a street level. I mean, data that radar on like more of a macro level doesn't collect. You're actually collecting this on the street level in a 300-meter radius. So very valuable. Let's go back to Matt.
I don't know if you guys seen, everyone's part of the Arden Tele group. I posted on there, there's a PLC that you can use, and you can tie that PLC. PLC stands for Programmable Logic Control. It'll accept all these sensors, and you can link that, because it's Wi-Fi and Bluetooth, to Arden. And it has MQTT also tied to that. So you can receive any information. You can also, if you want, you can interact with it to tell it to shut a switch off or turn the switch on. So it does temperature, wind speeds. You can also integrate it with the AI to calculate and negate the current weather with the actual weather.
It's a full-scale network at that point.
Pretty much that's what it is. But you can, this PLC, you can actually tie it into the Arden, if that makes any sense.
Yeah. I mean, because the Arden's just a pipe. It's just an IP pipe. So we could take any of this data, and it allows us the ability to send any. That's our conduit to get this data across the network, and we've got it here. It's already existing. So why not utilize it for some more advanced features?
So we're gonna go to any mapping here, it's like I've got the HAPC light, I need to, let me have a microphone. I have the HAPC light and I have the directional antenna. I was gonna point it at Steve, but is there anyone to sit around and say, hey, you'd be better off pointing it here? Are we gonna have any mapping like that at any time soon?
We have,
There is somewhat of a map right now. The only problem is it doesn't, a lot of the places, locations have sector antennas that won't indicate on the map whether you can get into it or not.
Where you located?
Like at Sandridge, we've got sector antennas. You can get on that. Granary, we've got sector antennas. So we're trying to get that, but we do have a map right now. Are you in on Arden yet?
No, I have not programmed
Okay,
anything.
I need to get you and Ken both in on that. You just buy a little node and that'll tunnel you in,
I think
and
said
then you
he
can go
already
from
has
there.
it.
Steve, those are sector antennas for Arden?
And I have the antenna, I just have
We need to
to
get 'em
program
tunneled
it. I
in.
don't know where to point
Yeah.
it at this point.
Okay.
To help the net.
Can you see, Sandridge from your house?
What's that?
Oh, are you talking about Meshtastic or Arden? Arden. Yeah, just, can you see Sandridge from your house?
Oh, yeah,
Okay, just point at Sandridge, you'll get it.
okay, that'll do it. Okay, okay.
We put that up, we put that up a few
5
months ago.
miles.
Where you located?
Yeah,
yeah,
Where you
we get
located?
it.
Where you
39th of May.
9th in May,
39th in May.
39th of May.
south of what?
North.
Yeah, you should be able to get on that northwest node.
Yeah, I can stand on my roof and see Stanbridge. So that's not a
Okay,
problem.
yeah, that
That
should
one's
be,
active and
that
it's
should be
pretty
a
good.
no-brainer.
Right. But I didn't know if it'd make more sense for me to
You
be
got,
pointing it
from
someplace
from
else.
the antenna, you'll be hitting, there's a 15-mile lake running through that antenna, so you should not have any trouble.
I think my antenna said something like 30 miles or something like that. I got so much information stuffed in my head right now on that that it ain't even funny, so I'll have to
9th
go back
in May,
and
that should,
reread.
Yeah, that's only about 7 miles.
15
Yeah.
kilometers, I think is what it said.
yeah, it should not be a problem. It should not be a problem whatsoever.
So, any ideas on the room about translation scripts for? You've talked about it before about translation scripts from taking Meshtastic data and bridging it to like an Arden network. Yeah, is it what you mentioned like Python, Matt? Or
Pretty much, you can just use Node-RED, Python, or, and then for visual, you can use Grafana. I'm sure a lot of folks are familiar with Grafana.
yeah, it's a data visualization software. And for those of you that don't know, Node-RED is it's open source, low code programming platform. It's designed for wiring together hardware devices, APIs, and online services. It was originally developed by IBM and their emerging technology team. It allows for a visual flow based editor. Users can drag and drop and connect blocks defined as nodes to create paths and logic, so there's no need to write code unless you desire. Pre-built nodes, there's extensive third-party libraries that integrate for MQTT and HTTP file systems. So there's your Meshtastic and there's your Arden. Runs on Pi or Linux devices. It's lightweight enough to run on a Raspberry Pi device. Why it matters to bridge in the mesh in the context of our hybrid mesh, Arden and Meshtastic network, it acts as the automation and visualization layer, connects those MQTT message topics to services such as alert dashboards, control triggers, and data logging. For example, a message published from a LoRa node saying flood detected could be intercepted by Node-RED, parsed, logged, and displayed visually and relayed over Arden and back to the field without manual intervention.
So another thing tied to that somewhat similar situation, if you guys run across any software that you think is cool or that's somewhat integratable, if you Google API, that you're golden. It's universal to pretty much anything. API, I can't remember what the API stands for, but it's a protocol that pretty much you can integrate to a good portion of Node-RED, Python, and whatnot. And
You mean just like application programming interface?
there you go.
Okay,
But
okay.
look for
okay.
those, you know, I just drew a blank. Those characters, if you find a software that you like, because I utilize APIs for my phone company, And I pull an API to kick out messages. I pull if somebody schedule an appointment, the API comes in, integrates, and then kicks it out as a messenger. And then I get an email, and this is all tied into APIs. So if that's pretty much kind of getting carried away from the Meshtastic and whatnot, but it's information if we go to the gateway mindset, where there's a gateway that manages everything. And we look at it. This is the dashboard. Gateway, the dashboard, which is MDU or MBU. And
Oh, absolutely. Yeah, I think having the API. I think there's a lot of APIs that you can call out for the offline large language models too. You can run those through an API, and I believe that's when I got the Mesh Gemini set up with the little AI running through Google Gemini, where I could send where my node would receive a message, it would receive certain messages, and the bot would respond. And Adam's got something similar going. So, yeah, all of this stuff is extremely cool with what you can do when you start to integrate AI into this network and do some real cool things with it.
The Arden nodes all push out their metrics in the format that Prometheus uses. So you can use Prometheus with Grafana to gather that information. Also, they do it with Node-RED, but I've never dealt. I'm trying to learn how to do it with Prometheus because that's what they all use.
Okay. Yeah, I did read that Prometheus, and I saw some people that were running Prometheus on the Arden network today. So yeah, that would be one right there.
Hey, Hoop.
Yes, sir.
Have you had a chance to play around with Reticulum yet?
I have not played around with Reticulum. I know a guy that has, though. He's right here in the audience.
Here.
It's great, but
Yeah?
there's only me and me on it, so I can talk to myself. I can do that without the reticulum, but it's really neat. I've sent myself pictures from a couple of miles away from the house. It works. It seems like it's more robust than Meshtastic, but then so's MeshCore. But again, nobody's in it, so I kind of let that go by the wayside because everybody's in Meshtastic right now. So it is cool. If anybody wants to get into it, it's another $32. You can get right into it.
Does it use the same hardware?
Huh?
Is
Exact same hardware.
Same
It's
hardware.
Same thing. Yeah.
Huh.
Yeah. It's pretty cool. It was easy to get going, and I'm just talking to myself because nobody else is on it. So
You want MeshCore?
yeah, I got MeshCore too.
I got one right here in my little Altoid scan. Yeah. So maybe we can try that one out and see how that works.
Okay.
All right.
It's just money, right?
Yeah. I don't have anything else. I appreciate you guys joining us today. We still got some time left, so let's take the time to network amongst ourselves. And thanks for coming. Thanks for coming out. Appreciate it. Thanks, guys. Take care.